So now I'm going to talk a little bit about what would an enterprise OWL ontology be. And this is really the, the bread and butter of a lot of the work that Semantic Arts does, is we go into organizations and we help them make sense of the information they have in their data systems. And part of it is just figuring out what is all this data about. And we'll go in, and a lot of times our initial engagement will be to create something called a core ontology. We say think big, start small. So when we think big, we're going to do a core ontology of the main concepts common to the enterprise, the ones that are central. And then when we'll start small with some small pilots, but they will initially leverage that big overarching ontology so that there's room to grow in the future. So an enterprise ontology defines a common core set of concepts. So these are the concepts that are central to an enterprise. For a financial service company, these might be things like accounts and transactions and customers and so on. The nice thing about this core set of concepts is that really it's relatively stable. Technology changes here and there, but the things that are central to a financial services firm or an architectural firm or a real estate company, those things don't change all that fast. It's a relatively stable set of concepts. And also we find in our practice it's relatively small, meaning we'll find there's maybe a few hundred total concepts that the business runs on. And that may seem kind of a lot, but the alternative is what's currently happening where you have multiple databases with each of multiple tables, and those tables have multiple columns. And if you think about the full set of concepts you need to understand, when you have, let's say, we've had even a client with a small data set that we worked with, they had about 700 tables and about 100 columns per table. And so that roughly is 7,700 concepts, and there are some ERP implementations that literally have tens of thousands of tables and hundreds of thousands of columns. And really, for someone to get their mind around all that information, they really have to understand tens or hundreds of thousands of concepts. So in our case, we'll get these often down to a few hundred, and people can actually get their head around them and understand what things mean. So that's what I mean by it's a relatively small in comparison with all of the tables and columns you would normally have to get your head around to truly understand what's going on in an enterprise. And honestly, that's why most people don't, right? It's such a mess. We have no idea. There's no real way to see all the data and all the information, and that's why integration is so difficult and costly. So one thing about defining an enterprise ontology like this is that it helps identify terminology conflicts that the enterprise has. It helps synchronize the case where you might have different words for the same concept, right? Different lines of business or different people use different words when they really mean the same thing. Also during this time, you'll see the opposite. You'll see the cases where the same word is being used for different concepts, that kind of ambiguity as to which one are you meaning. So doing an enterprise ontology, it takes some work. We will often spend 3 months trying to identify the core concepts with a client. But then it pays big dividends, because when you come up with this core set, and then over time you might want to go more deeply into a particular subdomain with a client, you'll find that you have a place to ground everything, and everyone's talking in the same with the same set of concepts. So it really, it's a little bit of work up front, but it eases integration all the way down the line. The last thing I'll say about an enterprise OWL ontology is these ontologies are formal models, meaning they actually have a mathematical basis, and that formality means they're computable, and you can actually, tools do automation based on these formal models. One of the things you can do is detect logical schema inconsistencies. So once you build a schema, and again, I'll show you an ontology later, and you might start get a sense of how that's possible. You define some terms in terms of other terms, and you build this network of meaning. And then if anything is inconsistent, the tools can tell you. Also, these formal models allow you to discover new facts in the data, meaning you can come up with new statements that were never explicitly stated, but you can tell through the logic of what has been stated that these other things must also be true. we'll see some cases of that. Just kind of a picture of what this might mean then. You kind of have this ontology model of concepts and their relationships to each other, kind of in this oval. And you can use that as a lens by which you can look at and often integrate into specific kind of siloed databases and the information they contain, or maybe as a way to view holistically your enterprise data lake. And you can map these common central concepts down into that data and understand what you're looking at. And you can even virtually or ETL them into a knowledge graph and actually query it.